Okay, we're on mass to volume problems, and in these types of problems, we're going to be using a flow chart, and the flow chart I'm going to have to write it out. The flow chart that you're going to use is going to look something like this, okay? So when you convert grams of A to moles of A, you're going to divide by the molar mass of A. When you're converting moles of A to moles of B, you're going to use the coefficients in the balanced chemical equation. And when you convert moles of B to grams of B, you're going to multiply by the molar mass of B. Now, if you're given liters of A to begin with, you can convert liters of A to moles of A by dividing by 22.4 liters. If you need to convert to liters of B from moles of B, you can multiply by 22.4 liters. Okay, now let's take a look at number 8. If an airbag contains 100 grams of sodium azide, which is NaN3, what is the volume of nitrogen gas produced at STP? So what you want to do is write the appropriate numbers underneath the substances in the balanced chemical equation. So you've got 100 grams of NaN3, so we're going to write that underneath NaN3 like this. They want to know the volume of nitrogen gas, so I'm going to write question mark liters underneath N2, and they told me that we are at STP, which means you can use 22.4 liters per mole, okay? So the first step is convert 100 grams of NaN3 to moles of NaN3. The molar mass of NaN3 is 65.02. You're going to set it up like this. And it's this many moles, okay? Then you're going to convert moles of NaN3 to moles of N2 in step number 2. So you start like this. You're going to take 2 moles of NaN3 from the balanced equation. You're going to put that on the bottom. And you're going to get this, okay? Now, in step number 3, you can convert moles of N2 to liters of N2 by using 22.4 liters per mole. And you set it up like this, okay? Multiply it out, you need 4 sig figs in your answer. You're going to get 51.68 liters of N2. Okay? Okay, now, in the second example, you've got a sample of sodium bicarbonate. NaHCO3 produces 0.5 liters of carbon dioxide gas at STP. So you're going to put 0.5 liters underneath CO2, and I'm going to make a note that's at STP. which means I can use 22.4 liters per mole. And we want to know what the mass is of the sample. That means they want to know the mass of sodium bicarbonate. Okay? So if we're starting at liters, you can convert liters to moles by dividing by 22.4. So step number 1 is liters to moles of CO2. And it looks like this, okay? And you're going to get 0.02232, okay? Then we can convert moles of CO2 to moles of NaHCO3 by doing a mole ratio. So it's going to look like this. And then you can convert moles to grams by multiplying by the molar mass of NaHCO3 in the third step. Okay, the molar mass is 84.01. When you multiply, you're going to get 3.75 grams of NaHCO3. So that's your answer, okay? And you have to follow the flow chart that I wrote in the very beginning. Okay,